Good morning and afternoon, everyone. Thank you very much for joining us here in December before the end of the year. Hopefully we're able to talk to you and educate and have a dialogue and discussion on process monitoring for adhesive validation. Before we get going, what we're going to do in the webinar series here that we have, we typically like to ask a few poll questions. And throughout the presentation, we're going to ask you some questions that allows us to kind of tailor our message to you and to our audience, and allows you to kind of look at how we would initiate an application discovery when we talk to you about a particular application. So in this first poll question, you'll see a pop-up menu come up, and it's going to ask you what industry are you in. And if you could select one of those options, that way we can, again, tailor the questions to your specific industries or to the most of your industries. Usually I give about 20 to 30 seconds to fill out the poll. And once we do that, I can kind of share the results so the rest of you know kind of where we're at. Okay, it looks like most of you, or half of you, have voted, I should say. Like I said, usually it's a pop-up window that comes up. You select the checkbox and submit. All right, so we have about 2/3 of you guys that have selected. I'm going to go ahead and share the results of this. So it looks like a few of you are in automotive, medical and packaging, a little bit above that, and other. If you could, would help us out a lot if you did select the other, if you could type in your industry in the Q&A box. For the questions and answers, and that way we can kind of again see where you guys are at and maybe tailor some of our discussions or even responses back to your industry. But thank you very much for posting that. So what is an integrated thermal machine vision solution? Well, we all have heard of vision solutions and automated vision systems utilizing color to help and aid in quality management of our manufacturing processes. What's unique here is we really adopted that to utilize the FLIR thermal sensors and cameras to be able to make those decisions, when a lot of times vision systems generally have some challenges or issues with that. And we're going to go through some of those in the presentation today. There are two types of process monitoring systems, two primary types. And one is condition monitoring, the other is process monitoring and control. That's the way we divide this up. Condition monitoring being the slower events, monitoring consistent based processes, identifying problems as they develop, looking at a fixed or a static scene. And when we see temperatures change over time, we want to alert someone about that. The temperature of this furnace is getting too hot, or there's a problem in a motor or a switch gear creating an excessive amount of heat. So we want to know about that before that product fails. The other side, on the process monitoring control systems, these are quicker events. These are events that require fast cameras, gig vision, high-speed cameras. They're continuously monitoring automated processes in an inline fashion. We have bi-directional equipment integration, so we're talking to the automation equipment, letting them know that something is a problem, or there's a problem or an issue with a particular manufacturing process. And we may want to control that automation equipment. We may want to look at saying, there is a problem, let's take that product off the line for further evaluation, or we don't want them in downstream manufacturing processes. So typical applications like we're talking about today, this is where adhesive inspection would take place. Any kind of joining systems, thermoforming, packaging, the list goes on. So those are some common ones that you guys may see. But in these process monitoring and high-speeder applications, we're actually doing inline validation systems, and that's kind of what we're going to be talking about here in this presentation. So what is this? What this is an ecosystem pulled together to give you a fully integrated thermal vision system. Okay, so we take the FLIR thermal cameras, we integrate those into a GIGI-based thermal machine vision software. We have bidirectional integration into the equipment PLCs or the equipment to take that process and to do something with it, right? We have pass, fail, or even adjust signals that we can make recommendations in what you want to do. Analytical statistical process charting for trend analysis and decision making. So we can look at why are we getting adhesive overflow or splatter in this particular area over and over and over again. It helps us really kind of find that root problem or that root cause analysis, and we can quickly identify, and what we have is, you know, equipment startup after shift change or otherwise, or tool change out, or barrel change on the adhesive barrels. There's a lot of indication of process failures happening in those particular instances. We do data retention, collection and retention. So what we want to do is, when we have an event that we are concerned with, we want to record and save that data. So we save the thermal images. We want to be able to have full radiometric information to be able to go back and analyze what the root problem is. We want that data into an Excel document, let's say, and we want to be able to look at, again, trend analysis. Why are we having issues on one particular part or one particular time in our manufacturing machine uptime? So there's a lot of good information that we can drive to find root problems. Cloud-based analytics. Look, we're all going to this cloud-based analytics or subnet analytics systems, where we're able to alert process engineers, quality managers, those that are responsible for the uptime of the system. So when we run into these problems, we want to make sure that everyone knows about it in real time to be able to go back and make any kind of adjustments. What we don't want to do is continue processing faulty parts or faulty manufacturing process, where we have to then check or scrap a lot of the parts, like a full bin or lot of them. So we want to have real-time communication to those individuals that are responsible for WIP and keeping products in uptime. So again, this is all to provide confidence in the process, optimum quality output, and give that quality inspection real time on each and every part. So here I'm just showing what the KPI, key performance indicator analytics and dashboards may look like. So looking at faults per hour, you know, again, that trend analysis. We can look at it on a per camera or per area of interest, where we're having more faults per hour, and other kind of key performance indicators that's important to you. Of course, we want to make sure that the data that we want to look at means something, and that we're able to correct processes, all with the end goal of high output and high quality process inspection. So, having that background of what it is and what we're going to be talking about as far as some of the things that we've seen out in the industry and fields is, what do you need in a dispensing system? I'm sure you all would agree that to dispense an exact amount of material at a specified location on a very repeatable basis, that's what we really want. We tune these machines in, we tune the robots in to do the application, and we don't want any falter from that. Yeah, we obviously do not want any leaks in our leak testing. We don't want any downstream quality inspection WIP buildup to happen, where we have to slow our production lines down. And we want to prevent waste and rework on parts. Look, we often are called out to sites and firms where we have issues on, well, we inspect everything. We do a leak test after the part is joined. And more times than not, once that part is joined with the adhesive and we do a leak test and we find a failure, not only is that part scrap, but subsequent we've seen up to 60, 70 parts behind that have to also be scrapped or quality checked in order to understand where that break is, because the inspection process is so far downstream from the adhesive dispensing process. So we've done a lot of other things in the manufacturing process before we get to leak testing that now we have to throw that lot away and or try to do repair. And of course, repair, even if the part can be repaired, look, I mean, you have your quality staff that are leak testing and validating, and maybe even doing some repair, and the WIP gets really built up there. And we've seen a lot of pressure out in the field to make sure that we can, that line retains its ROI metrics and its throughput metrics. So common issues that we've seen in the field, and you guys may have some more, but common issues with adhesive dispensing systems is inconsistent dispensing, right? This could be clogged dispenser heads, this could be air pockets, this could be a number of different things. But what we know is that we're not getting consistent dispensing out of the heads and onto the parts. Clogged dispenser heads, of course, you get in there, the dispenser head has maybe some viscosity issues, maybe start and stop of the machines. But what ends up happening is that you have dried or a cooled material in the head, and we're not getting consistent throughput. Air pockets in line, big, huge problem that we've seen out there, especially in barrel changeover in the lines. When we do barrel changeover, air is sometimes introduced into the changing of the barrels, and that can create obviously voids and gaps in our adhesives. It can create sputtering out on the product, which will cause quality problems. Viscosity, we want to heat this material up to a certain temperature, and depending on your material, you have different parameters, of course, of what temperature that adhesive needs to be to properly be dispensed. And when there's variation in the line, now you could have plant variation, you could have ambient temperature variation. There's a lot of things that could change, that can make that change over time. You could have actually a problem in the heater system that you would know about until you do the leak testing, and you have to throw out those parts. So there's a lot of issues with viscosity. Now, one of the more uncommon, I know I put this on the common issues, but they ended up being common that people really don't think about, is part warpage. We've been at customer sites where you have a plastic part, let's say, and it's coming off an injection molding system, and there may be some issues with that upstream assembly process or processing equipment. And when the robot, while tuned very specifically and very accurately where to dispense that glue, if the part is not setting in the nest correctly, or if there's warp in the part, what ends up happening is that you're not dispensing that adhesive at the same location at the exact same time. So again, when we marry the two halves together for that bond, what we're then seeing is that you're not getting the correct amount of adhesive in the trap that you want to see it, and then it's causing of course leakage and part scrappage. So inconsistent airflow is the last one. If we have inconsistencies in our airlines at a plant, or if another machine starts up and takes a lot of that air, that can affect the output of the dispensing product onto the part. So a lot of these variations. And I think that when we go to a plant and we see these are the problems, and I'm probably hitting 3/4 of them all, but these are the main problems that we see. This is a very large task, I should say, of getting your head wrapped around how do I ensure that I'm not going to have viscosity issues or inconsistent air issues or part warpage or air pockets in my line, different things like that, or clogged dispenser heads. I mean, that's a lot of variables that you have to control in order to have a repeatable, consistent, and reliable dispensing system. So those are the common issues. What I want to do now is ask another poll question. Do you struggle with establishing the root causes for your defects or your leakages or on your product? So I'm going to launch this poll. Okay. And we'll give you 20 or 30 seconds or so to answer the questions, and I will share the results. A lot of times when we are out in the field and working with plants, we ask that question. What is the root cause of your defects? And we get a varying variety of responses to this question. And we get issues like, well, I think the robot's out of tune, or I get we're placing too thin of glue in this area, where we're in this other area it's too thick. We just get a host of different responses, and it kind of made us think about all of the different situations and scenarios that do happen in a production environment. Our main goal in a plant, right, is to produce parts, but not constantly trying to go back and troubleshoot why am I not getting that repeatable, reliable, and consistent process. So I'm going to close the poll here, share the results. So the majority of you did say yes. I do struggle with this root cause and understanding what those defects are. For those the 38% of you that said no, I would assume that you know exactly what the problem is, but we're unable to control that problem. Or moreover, I have a problem, I know what to do, but we're constantly changing those variables or those states. And what I want to do is know exactly when I run into that problem so I can repair it faster, right? So those are the two different scenarios that I could see with some of your results. But thank you for that. So what I'm going to do for this next section of the presentation is really kind of go through some of the applications and the challenges that we have seen out in the field, and maybe some of these will relate to you, maybe some of these that applications that you may have a good tie into, and maybe some of them that they might be very close or actually your application. So the challenge here, this is for packaging box and looking at seal quality inspection. So we had cardboard boxes and plastic actually boxes as well, where they were married. We had to validate. What we wanted to do is validate the glue. So the challenge was find a non-destructive way to detect incorrectly sealed boxes. We want to remove these units from the line, of course. We don't know the temperature of the adhesive being applied, but we know that they're at a warmer temperature than the substrate or the box. And we want you guys to generate an alarm if too many boxes fail. So maybe one box that falls under a good radar for us, or maybe three. But when we see about 5 in a row or 6 in a row, we have a situation. I want to be notified of that. So we want to look at trend analysis and statistical data of pass and fail. What we were able to do to help this customer out was first set up a camera, and we clearly saw that we had what we call thermal contrast, a temperature differentiator between the adhesive and the substrate being applied. Many of these types of applications, while we're not ultimately concerned with the absolute temperature of the glue and what that characteristic does to our process, in most cases we want to know that it's been applied. So it has presence, it's been applied in the right location and the right parameters, the right area, maybe on X and Y coordinate. We want to make sure that those parameters exist, and that's our quality control metric, our key performance indicators, whether or not we pass or fail those. So we were able to go out, look at the blob sizes. We were able to one, detect the presence. Do we have glue there? Yes or no? Check. Okay, if the glue is there, do we have the right blob size? Do we have the number of pixels needed in this particular area to say that we have enough glue in this area to hold that flap of the box down? Check. And then the last thing is, do we have the right spaces in between each of the blob analysis or the blobs to not oversaturate that particular product? Check. So once we've checked all those 3 parameters, we're able to come back to the equipment PLC and say, yes, you have a pass part, you have a good part, and proceed. These, if we saw that we didn't have enough glue in a particular area, or if it was in the wrong location, then we would send a fail signal back to the PLC and say to take this particular product off the line. So this was a successful project, and I know that many more have been done throughout the world on doing these type of packaging or box seal inspections with glue and adhesive. But this was a very neat project. Another one's glue ring inspection. This is in concert with foil seal inspections, and this can get you know, there's many layers to these types of applications. But the challenge here was glue doesn't always get applied properly or at the desired location. There's gaps, but we also get splatter of glue outside of this particular area, which is not good. Our dispenser, we do know that it clogs often because we don't have a repeatable process of dispensing. And equipment startup is costly and time consuming. In this particular, you know, we've seen applications where you start you start a certain process. If you have to pause that, it affects 15 other downstream processes, and you get width buildup and even gaps. And so it became very processed. And this is very common in the industry. But this particular process, what we're looking at is identifying the glue in the ring, or any kind of shape for that matter, but in this case, the ring. We want to make sure that when it's present, that we have uniformity across that ring. And do we have the right thickness? Do we have the right width, I should say, of the adhesive being put down? If we don't, we have a thinning area, and that will cause a leak. We've done another application. I don't have the images here, but if we looked at an area that had thin glue, while it might stick and be adhesive, the problem is that it had to withstand like a 9 psi burst test at a certain stage, and you have to wait till the adhesive cures and sets. Well, if it gets downstream and we do not hit that 9 psi burst test requirement, then what we have a situation is we have to revalidate. I think it was 116 products behind that from when the failure was identified in the quality inspection to the manufacturing process. So it really created a negative ROI effect, and utilizing the thermal imaging, it at least let them know that we have a problem now. It was in line, real time, and we could go back and repair the processing equipment to look at this. But the method that we typically use on this is we use blob analysis to find the thermal ring of the adhesive. So we dynamically find where this adhesive is present, and then we draw tools, region of interest or areas of interest tools around that using blob analysis. From there, we do pixel density mapping. So we count a number of pixels in a particular area, and those pixels must be greater than a required value. So if we have, let's say, 200 pixels that we need to see in this temperature range, we validate that is enough glue or adhesive in that particular region or specific area of interest. If we're short of that density mapping, then we know we have a weak bond, or we're going to have a weak bond, I should say, once we marry the products, and that will cause the leakage. So very interesting project. They can get very deep and very somewhat complex, but the result is very good of doing this process control. And typical vision systems, especially if you're using adhesive that's, let's say, black adhesive on a black product, that's very challenging for a standard vision system. But we try to play the same analytics and validation processes with the thermal imaging. Here's one of a very fast-moving product, Shingle adhesive inspection. It's a very unique project where looking at glue strips coming down the line. So the glue strips are necessary for proper installation and adhesion between each of the stacks. Clear glue on a black shingle is not clearly visible, and it was difficult for a standard vision system to see this. We wanted to reject the product missing the strips and get them quickly off the line with the diverter arm, and they wanted to automate manual inspection and large batch sorting. So basically, the number of units or shingles that were being produced, if we had 2 seconds of a thin glue or even a void, that created a very large amount of product that was unvalidated or that wouldn't meet the requirements. So the amount of product waste was enormous in this particular project. So it was really critical that inspection bead that was clear and present to validate the product. If we saw a slight variation, we basically kicked that off the line because of its fast travel, right? I mean, high speed product on the transfer belt going down the line. So this was one of those situations too that you want to look at not only presence, but we want to look at finding dynamic regions of interest. So using blob tool analysis, finding those edges and making sure that it's within a certain width. And basically traveling that. And again, I want to say it looks like a snake when you see how fast this is going down the line, but what it does is you want to have that dynamic movement of the region of interest or the specific area of interest, and then doing those calculations. Now, these camera calculations, by the way, calculate in about 0.8 of a second. So on a frame rate, we're only catching every fifth batch of shingles coming down. So decision making, again, had to be very quickly, even processing at about 0.8 of a second. Here's one that we did for a bathtub pan. And looking at bathtub pans, we were pretty educated in the process. I didn't know there's so much into making our bathtubs that we use every day. So, they have a liner attached to a base and a robotic arm that sprays product or adhesive to make these two part halves join. So the challenge here was inconsistent glue dispensing. There was inconsistent coverage applied to the product. They got really bogged them down with clogged glue heads. Inconsistent Q&A due to manual and operator inspection. So basically, once the product was sprayed, the operator was to visually inspect this product before it was married to its shell, and this product in fact was clear onto a white frame, the subshell underneath the pan of the bathtub. So it was kind of difficult. While you may be able to see whether or not glue was applied, if you can see in the image here, I don't know if you can see my mouse, but there is a specific, there could be a line that was missing on the edges right here. So you see these two edges where we're not getting enough coverage from the adhesive. So that causes their peel test or their pull test requirements, they would fail. And again, they produce 30 or 40 of these tubs and find out one fails, then they have to reinspect all of them. And once you do a destructive test, if you can't do leak, destructive testing, as you guys would know, that product is then scrapped. So really what you do, you have to find the first and the last product that may be of interest, of a potential failure, and you have to scrap that many units. And that was, again, very costly. So we were called in, and once this customer was educated on the value of thermal imaging, being able to see these streaks. And so we were able to do inline processing. And then in this particular process, once they got this out there, they actually turnkeyed this. So once they saw that the glue, in this particular case, the head was missing this strip, they actually, because they could do a lot of overlap. I know a lot of your applications you may not be able to go back and repair with a robot due to cycle time, or due to you can't apply a second layer of adhesive. But in this particular application, they just asked the robot to go over and do one more pass. And even though we double layered on much of it, those areas that didn't have any adhesive or very little was covered up adequately, and they were able to pass quality inspection. So this was a pretty fun project to work with. All right, have another poll question for you. In your particular areas that you guys are responsible for, do you have a reliable automated quality inspection system in place, in line, let's say, within your process? I'll launch the poll here. Okay. we've seen two different thought processes on inline quality inspection, where some of the folks that we've seen have maybe pyrometers, or maybe even vision systems, or operator manual inspection. But typically, it's not in line with right after the dispenser system. It could be down the line of the process, or the robot has to flip around the product in the bathtub case where they're looking at it and doing a visual inspection. But it's very difficult. They can't see heat, so what they're looking for is gloss or reflection from the adhesive. So I've seen a lot of different things like that. But it looks like the majority of you, I'll share the results here, the majority of you said, no, I don't have one of these. And that's typically what we have seen out in the industry. You know, the ones that don't have it are like, well, you know, yeah, we need something here, and thermal seems to be a very good technology to be able to give us that validation. The ones that maybe have something that we've been out there, they've tried a pyrometer, maybe a vision system, and in that particular application, they're just not working well. So they want to try to move on to a more reliable system. Again, what's the goal? To dispense the right amount of product at the right location at the right time. So if your current inspection system is not giving you those, and you don't have a way to validate whether it is or not, something thermal you should really take a look at. Okay. A few more here for you guys. So shoe adhesive inspection. So this is a unique application that we did with the challenge being glue presence through standard machine vision verification did not prove reliable or repeatable. In this particular instance, the problem really came down to in the plant, there's a lot of reflection. There was a lot of shadowing happening and in the process, and the lighting system that they were employing didn't really lend itself well because of the absorption rate of the product compared to the sole of the shoe, and so finding issues or gaps or oversprays were difficult. There are other problems where even coverage, the gaps in spray, inconsistent part-to-part processes. So the shoe sole 1 to 2, we would have inconsistencies in that. When the operator would see these things in the visual system, he would make adjustments to the machine. And by the time he made the adjustments to the machine, he'd see some errors and he'd adjust back. And it kind of went back and forth too frequently, is what they were telling me. So it was constant chasing the tail of tuning in the process. And of course, they had way too much waste. So again, a very unique product where we had left and right hand shoes coming down the line, or soles. We had different sizes coming down, another variation of sizes. So we couldn't use fixed region of interest or area of interest location. This causes, of course, you'd have to have a lot of programs saved to be able to call those up, and we didn't have a consistent way of doing that. So what we ended up using in this application was, again, blob analysis, and we would dynamically draw regions or areas of interest. And on the top image here, you can see that while drawing that, you have a lot of inconsistencies and gap based off of the thermal mapping and what we were expecting as the optimum temperature range to validate enough adhesive and primer were applied. And here, this was a good product showing that we have a uniform coverage around the sole. And this was a past product. So what's nice about the thermal vision systems, you don't necessarily have to do image mapping. I know a lot of systems do that, but it becomes a little bit cumbersome in when you have left, right, and then a lot of different sizes coming down the line that are not in batch processes. So when they're not in batch because they're coming off multi-lane cutting systems and coming into and funneling into this adhesive, then you don't have that consistency, and it's very difficult to do that. So that's why we employed the blob analysis and visiometric tools to be able to do the pixel density mapping. So very, very fun and interesting product. This was done about 5 years ago. We often check in on this customer, and they're still plugging away at it, and they love the system. So that's really good news. Automotive moonroof sealant verification. I'll quickly go through this one, but this problem, air bubbles. If those of you guys have seen this, you have air bubbles. They can form in the lines, causing breaks. They can cause thin glue and breaks. Stopping dispensing process caused the thin glue. So when the robot head started and stopped dispensing in certain areas, they got thicker blobs. And you can kind of see that in the thermal image here, where you see the start and then stopping. They didn't have a very controlled process, but they kind of knew that. Just this thermal image kind of outlines that error. Existing IR sensors, they have pyrometers put around here just for presence, but the problem is you have to use a lot of pyrometers. Imagine this: a camera, one thermal camera is like having over 307,000 individual pyrometers or temperature measurement thermocouples. So you'd have to place a lot of them around here to really get a full picture of what's going on. This was a black sealant on a black background, so the standard vision was not a viable solution for them. And of course, they had leaks in this with the brakes. So again, thermal imaging, we map around here saying this is where the adhesive should be present. This is the start and stop, and we want to validate that. A pretty simple and simple process, and it was highly successful. Here's an automotive glue inspection process. The vision system was not effective. Again, dark adhesive on a dark product. In this particular case, they had a lot of issues with the glue bead falling off after robot dispensing, and that had to do with this part being metal and not at the right temperature when the adhesive is put down, so it kind of crystallized, and then the adhesive would fall off. It was not always placed with certain accuracy. There's a lot of moving parts. It's a big automotive framing part, a really large part, and it was kind of whipped around a little bit with a end of arm tooling on a robot. So that caused a little bit of process issues. So they wanted to make sure that it wasn't falling off. And of course, they could apply rework to this, but an operator had to go and scrape off all the previous glue, get it off on a center, scrape all the glue up, bead off, sand it down, and put it back into the line again for re-application. So a lot of rework and a lot of wasted time on this product. So what we did was we validated that the adhesive was present and that we didn't have any gaps or breaks. And their primary concern was that adhesive falling off because they didn't have the right temperature of the substrate to the adhesive. And that caused, obviously, the two parts not joining. So that was a unique one that we did, but highly successful product right there. Here I have a video going. If you guys can see this video, this is on a headlamp unit in the automotive industry, to a robot on the left and right hand side of the vehicle applying the glue. This is a unique project because it started off by, we want to know where there are voids, and the voids could be caused by, we've talked about them throughout the presentation, a lot of voids caused by certain process variations in air pockets in the line, clogged dispenser heads, so on and so forth. Really where it got down to is we did gross void. This customer then said, well, wait a minute, now I want to look at thin glue bead. And I want to look at when I'm not getting enough material down. If you can see in the frozen image here, well, let me pause it. You're able to see maybe some of these voids, or they're not voids actually, they're actually thin glue up in some of these areas. While we still have glue there, they were thin, and they're like, well, sometimes it passes leak testing and sometimes it doesn't. The issue with that is, well, how does a system really kind of determine what thin glue is and what thin glue isn't as far as a pass or fail? What would end up happening was the channel in which the adhesive was applied. It was, imagine a U-shaped channel. The parts, these plastic parts coming out the injection molding process, had warp into these bridges and these warpage on the walls. So when the robot went to apply them, some of that adhesive got placed not in the channel not in the bottom of the channel where it's supposed to be. It actually got applied to the wall of the channel. And that adhesive, sometimes when the lens was pressed down on this particular product, it would push that adhesive down into the bottom of the channel and create a good seal, or a decent seal, enough to pass quality. And other times that adhesive would stay on the wall and get squeezed outside of the channel. And there you would have, of course, a leak product. And this particular customer, unfortunately, by the time they were able to notice this, we're applying this adhesive to a 12-cent part. By the time the lenses, optics, and then they annealed them, cured them, and then leak test them, they actually end up being a $54 part. And once it's been married and joined, that part is now scrapped. There's no repair method to repair the lens. Worse over, they've already produced, I think it was 68 parts by the time the the leak detection system was applied, and they knew that they had a problem. They've already produced 68 parts before they could shut that line down and understand what was going on. So a very interesting project. This project actually is continuing on multiple lines, but here again, thin glue versus gross glue void is something that a lot of customers start looking at just voids, and they want to look at thin glue. Here we use, again, pixel density mapping using blob analysis, understanding how many pixels we're able to see. In the image down here, you're able to see a break, and we do not see enough pixels of contrast in here, thermal contrast, to be able to make this a pass part. So we actually failed these regions right here. We did not apply the expensive lens to this product. We told the robot not to do the marry, and then they threw away 24 cents of a part rather than $120. So very interesting project. This last challenge, this was on an exterior door panel. The process presented voids, again, due to a lot of the situations that we saw here or talked about. Mostly during barrel changeover, air was introduced to the lines, and we had dirty dispenser heads. So again, same kind of systems, but here we see gross voids into the adhesive process and thin glue. So again, a validation system before we do the joining. This product was not able to be repaired in line. It was actually, we told the robot to pull this off the line and do the inspection, and then that's where the operators again had to manually peel the existing adhesive, multi-bond adhesive off, and replace this panel back into the manufacturing process. But again, rework in time was their major return on investment issue that they had. And this is one of the same, showing the thin glue versus the breaks in the adhesive stream here. So using blob analysis and doing counts of pixel density mapping is what we call them, making sure that we have the right amount of pixel in a certain area to make that decision. So standard vision systems had difficulty with this one as well, so we were asked to come in with a thermal vision system. So to wrap this up, why use infrared technology? Here again, validate proper placement of the applied adhesive. We want to check for adhesive voids. We want to check for the width, potentially. We want to confirm that the proper amount of adhesive is applied, and ultimately eliminate the waste and equipment downtime. Okay. Equipment integration, being able to provide the pass-fail results back to the equipment in line in real time. Collect data for that trend analysis and be able to find root cause of the defects or problems and try to fix those before we produce too much scrap. We want to be alerted at first sign of any kind of dispensing issue. We don't want to wait till 70 parts run down the line and we leak test and then find out we have to validate or throw away 70 parts. So we want to know first sign that we're having issues, and we want to reduce the leaked parts and scrap and negative ROI placement into our manufacturing process. So that's why we want to use that. In summary, we do the inline 100% verification on all the parts. We identify upstream manufacturing process errors and issues with that trend analysis and trying to find out where our common thread points are of those issues. We prevent scrap and unwanted parts into subsequent manufacturing systems. We do not want these to go inline downstream systems to find out that we had the problems. We can reduce WIP issues in those situations, and we want to provide the quality and production measurements to meet customer requirements. Now, this information and data can be applied. There's no situation where you're going to get your customers coming back and saying there's warranty issues or stop calls or stop ships, I'm sorry, back here, because now you have the data saying, when we ran this batch of parts, these were our metrics, this is our validation system, and this is our process. So you do have that validation. So that's why we'd use those. And that's the end of my side of the presentation. I'll hand this over to Amy.
I do want to make everybody aware that we are continuing the automation webinar series into 2020. The next event will be held on January 14th. It will be automated thermal pouch inspections for packaging. It will be presented by MovieTherm. And then in February, we are doing monitoring refractory line vessels with Viper Imaging. All events will be posted on FLIR.com, automation training, along with the recorded webinars. So please feel free to visit us at any time, register in advance, and we will send you out the advance notifications as each webinar gets closer. Thank you, everyone.
Thank you, everyone. Have a great day.